Hello, my name is Nicholas Nikolic, and you are listening to the Android Book Tutorials. These tutorials are based on the Creative Commons work of Mark Murphy, who kindly released versions of his book, The Busy Coder's Guide to Android Development, and as such, these videos are released as Creative Commons as well. I will read from the book and go through the points directly. You might be warned that at this time I cover up to Android 4.4, whereas the original subscription book is updated on a quarterly basis and covers Android 6 and N and beyond. For completely current versions of Android, please purchase a subscription to Murphy's book at commonsware.com. It's quite likely some words about resources. New chapter. It's quite likely that by this point in time you are chomping at the bit to get into actually writing some code. This is understandable. That being said, before we dive into the Java source code for our stub project, we really should chat briefly about resources. Resources are static bits of information held outside the Java source code. Resources are stored as files under the res directory in your Android project layout. Here is where you'll find all your icons and other images, your externalized strings for internationalization, and more. These are not only separate from the Java source code because they are different in format, they are separate because you can have multiple definitions of a resource. So to use strings for different languages, to use in different circumstances. For instance, with internationalization, you will have strings for different languages. Your Java code will be able to remain largely oblivious to this, as Android will choose the right resource to use from all candidates in a given circumstance. For instance, choosing the Spanish string if the device's locale is set to Spanish. We'll cover all the details of these resource sets later in the book. Right now, we need to discuss resources in use by our stub project, plus one more. String theory. New subheading. Keep your labels and other bits of text outside the main source code of your application is generally considered to be a very good idea. In particular, it helps with internationalization and localization. If you're not going to translate your strings to other languages, it's easier to make corrections if all the strings are in one spot instead of scattered throughout your source code. Plain strings. Generally speaking, all you need to do is have an XML file in the res values directory, typically named res values strings, and then with the file strings.xml with the resource's root element. One child string element for each string you wish to encode as a resource. The string element that takes the name attribute, which is the unique name for the string, and the string text element containing the text of the string. So, for instance, you see here the resources XML base, and then string quick brown fox, and then string, and then he who laughs last laughs hardest. So there we are. The only tricky part is if the string value contains a quote or an apostrophe. In those cases, you'll want to escape those values by preceding them with a backslash. For instance, there are times that try men's souls, and a single quote is backslashed or escaped. If it is just an apostrophe, you can enclose the value in quotes, the opposite, single quote, double quote, or double quote, single quote. For example, our sub's project strings XML file looks like this. We will reference these strings resources from various locations in our Java source code and elsewhere For example, the app name string resource is used in our Android manifest.xml file. App name string. Where might that be? There we are. That was an activity. And label app name. Okay, so here are the Android label attributes. Here, the Android label attribute of our application element refers to the app name string resource. This will appear in a few places in our application, notably in the list of installed applications and settings. So if you wish to change how your application's name appears in these places, simply adjust the app name string resources to suit. The syntax @string /app name tells Android to find the string resource named app name. This causes Android to scan the appropriate strings XML file or any other file containing strings resources in your res values directory to find app name. Styled text. Many things in Android can display rich text where the text has been formatted using some lightweight HTML markup, such as B tags, I tags, and U tags, bold, italics, and underlined, respectively. Your string resources support this simply by using the HTML tags as you would in a web page, and then it shows the description of using B tags and I tags. Unfortunately, the list of supported tags is undocumented. Based on recent Android implementations, it will most likely be your inline markup rules. For instance, TT, H1, small, strike. All those are elements. The directory name. Our string resources in our stub project are in the res values strings.xml file. This directory, res values, means that the string resources in the directory will be valid for any sort of situation, including any locale for the device. We will need additional resources with distinct strings.xml files to support other languages. We will cover how to do that later in this book. String resources and Eclipse. Again, we're not using Eclipse. But if we open up we can open it over here, and then you see that we have a key and we have a value, and we can edit them here or edit it straight in the XML. It's up to you. The world's a beautiful place. Okay, so let's go on. By the way, feel free to get back to me regarding whether or not you prefer to have the code at all times in front of you on the video, or the book in front of you on the video, or both. We can try both, but in the meantime, let's just have the code. All right, so next subheading, got the picture. Android supports images in the PNG, JPEG, and GIF formats. GIF is officially discouraged, however. PNG is the overall preferred format. Android also supports some proprietary XML-based image formats, though we will not discuss those at length until later in the book. The default directory for the so-called drawable resources is res drawable. Any images found in there can be referenced from Java code or from other places, such as in the manifest, regardless of the device characteristics. However, your stub project does not have a res drawable directory. And we can see that, as a matter of fact, it does. Oh well. So just the change from this version of the book to the current version. So these refer to distinct resources. The suffixes -mdpi, -hdpi are filters indicating under what circumstances those images stored in those directories should be used. Specifically, -ldpi indicates images that should be used on devices with low density screens, around 120 dots per inch, or DPI. The -mdpi suffix indicates resources for medium density screens, around 160 dpi. HDPI indicates resources for screens around 320 dpi. Oh, excuse me. High density screens around 240 dpi. Extra high density XHDPI indicates extra high density screens around 320 dpi. And then we have more extras. Indicates extra XX HDPI indicates extra high density screens around 480 dpi. And then there's extra high density screens around 640 dpi, and so on. So inside of each of those directories, you'll see an IC launcher ping file, which we don't have here in our drawable directory because we haven't downloaded the code. We're going to be building it from scratch. This is the stock icon that will be used in our application in the home screen launcher. Each of the images is of the same icon, but the higher density icons have more pixels. The objective is for the image to be roughly the same physical size on every device, using higher densities to have more detailed images. For example, our EMPubLite tutorial project has res drawable HDPI, res drawable XHDPI, res drawable MDPI, and res drawable LDPI directories containing stock launcher icons for some of those densities, along with perhaps other icons. Our Android manifest XML file then references our IC launcher icon. So we can see here, where is it? We see here is in MipMap. Let's take a look at MipMap. When you refer to this directory and this directory, you needn't necessarily use the .png or the file extension at all. Just be aware of that. Note that the manifest simply refers to a @drawable IC launcher telling Android to find a drawable resource named IC launcher. The the resource reference does not indicate the file type of the resource. There is no PNG in the resource identifier, meaning you cannot have launcher PNG and launcher. This means you cannot have launcher PNG and launcher JPEG in the same project, as they will both be identified by the same identifier. You will need to keep the base name, file name sans extension, distinct for all your images. Also, the drawable /IC launcher reference does not mention what screen density to use. This is because Android will choose the right screen density to use based upon the device that is running your app. You do not have to worry about it explicitly beyond having multiple copies of your icon. If Android detects that the device has a screen density for which you lack an icon, Android will take the next closest one and scale it. So, for our stub project, Android would take the HDPI icon and scale it up to work with XHDPI displays, such as that found on the Galaxy Nexus, Samsung Galaxy Nexus. Drawable resources and Eclipse. I may just skip this part. Okay. Using Android system drawables. Android has many icons and other images that are considered to be part of the SDK, in addition to many drawables that ship with OS but are not considered to be part of the SDK. You are welcome to use these if you wish, though there are some things you to remember you may wish to consider. Directly referencing SDK drawables. Just as we can reference drawable IC launcher from our own project in places like the manifest, and later on from image view and image button widgets, we can reference Android system drawable. An Android system drawable instead of drawable, we use @Android :drawable/ like this. See that? Okay. Anywhere that we want to use a drawable resource, if it's from the system drawables. However, there is a risk. Device manufacturers are welcome to replace these drawables with their own artwork. That is not directly a problem, but if you are using some of your own icons in addition to icons that come from the SDK, you could get into trouble. Even though your icons might match those you see from the SDK in the emulator or on some devices, it is entirely possible that on other devices the SDK supplied icons will look different than your custom ones. Your custom ones might be grayscale, while the device's icons are in color, for example. Hence, you should only directly reference SDK drawables this way in situations where, even if the device's drawable is slightly different than you'd expect, your app will still look okay. Copying Android system drawables. You can find the actual artwork for these SDK drawables and many others in your SDK installation itself. This is a good tip. Go to the directory where you installed your SDK, Android SDK. In there, go into Platforms. In there, choose the API level. And then in there, go to Data/Res. And then in there, look at the various drawable directories, such as drawable HDPI. These icons are licensed under the Apache license, the same license that is used for the rest of Android. Therefore, you are welcome to copy them for your own project under the terms of that license. This is a safer approach. Copying is a safer approach than directly referencing those system resources, because by copying them into your project, you're using your own local copies with normal drawable references. If you are insulated from any changes that might be made by the device manufacturers. On the other hand, it does require a bit more work, and it will make your app a tiny bit larger. Dimensions. Dimensions are used in several places in Android to describe distances, such as a widget size. There are several units of measure available to you. PX means hardware pixels, whose size will vary by device, since not all the devices have the same screen density. The roughly for inch Galaxy Nexus and the roughly 10-inch Motorola Zoom have almost the same number of pixels in vastly different sizes. Inches and millimeters for inches and millimeters, IN and mm for inches and millimeters, respectively, based on the actual size of the screen. PT for points, which in publishing terms is a 1/72nd of an inch, again based on the actual physical size of the screen. And then DIP for device independent pixels. One dip, I like to call them dips. One dip equals one hardware pixel for a roughly 160 dpi resolution screen. But one dip equals 2 hardware pixels on a roughly 320 dpi screen. Dimension resources by default are held in dimens, dimens, .xml file in the res values directory. That holds your strings. To encode a dimension as a resource, add a daemon element to the daemons .xml file with a name attribute for your unique name for this attribute and a single child text element representing the value. Excuse me. Just doing a little bit of Okay. So the resources dimensions file is, some values, and then here's the dimensions. And you see the resources with the daemon attribute, DIMEN, short for dimension. And then here is the 16 DP. Or dip. Directory. Not directory, unit. Alright, so dimension resources by default are held in that file. In a layout, you can reference the dimension as @daemon, DIMEN, / whatever value. Whereas the ellipsis in a placeholder is a placeholder for your unique name for the resource. Thin and fat from the sample above. I take offense at that. Anyway, in Java, you reference dimension resources by the unique name prefixed with a r .daemon. For instance, resources get diamond, get r.diamond.thin. While our stub project does not include dimension resources, we'll be seeing them soon enough. The resource that shall not be named yet. Your stub project also has a res layout directory, and that, in addition to the ones described, that is for UI layouts describing what your user interface should look like. We will get into the details of that type of resource as we start examining our user interfaces in the upcoming chapter. And that looks like we're at page 77. We're going to take a quick break, and we'll start recording again with tutorial number 4, adjusting our resources.